Right, let's talk sequences for your GCSE higher maths revision. If they've been giving you a bit of a headache, you are in the right place. In the next few minutes, we are going to absolutely nail everything from the simple patterns to those trickier quadratic ones. Let's get you ready for that exam.
So here's our game plan. We'll kick off with the basic rules. Then we'll master how to find the nth term for linear sequences. After that, we're going to tackle the big one, the quadratic sequences. And finally, we'll run through some special sequences that are basically free marks if you know what to look for. Let's dive in.
Okay, first things first, let's decode the rules. You see, every single sequence, no matter how complicated it looks, is just a pattern, and every pattern has a rule. Your job is to figure out which of the two main types of rules you're dealing with.
On one hand, you've got the simple term-to-term rule. It just tells you how to get from one number to the next. Add 3, double it, that kind of thing. It's fine for finding the next term. But what if the exam asks for, the 100th term? You're not going to sit there adding 399 times. That's where the position-to-term rule, the nth term, comes in. It's a powerful little formula that lets you find any term you want just by plugging in its position. It's a total game changer.
So how do we actually use this formula? Well, let's say you're given the rule 4n-1. To find the very first term, you just plug in n equals 1. So 4 times 1 minus 1, that's 3. Want the second term? No problem, n equals 2. 4 times 2 is 8, minus 1 is 7. You just keep plugging in the position number to generate the sequence. It's as simple as that.
Okay, awesome. Now let's flip that on its head. What if you're given the sequence and you have to find the rule? This is a super common exam question, so listen up. We'll start with the nice ones, linear sequences. That's just a fancy way of saying the gap between the numbers is always the same.
And here's the secret. Every linear sequence follows this format, an plus b. Now the a bit is the easy part. It's just the common difference, the number you're adding or subtracting each time. But b, this is a great little trick. We call it the zero term. Just imagine taking one step backwards from the first term. That number is your b.
Let's walk through one. Take the sequence 5, 8, 11. First step, what's the difference? Well, it's going up by 3 each time, so a is 3. That means our rule starts with 3n. Now for that zero term. We start at 5 and step back by our difference of 3. 5 minus 3 is 2, so b is 2. Just stick them together and you've got your rule. 3n plus 2. Done.
All right, time to level up. This next bit is purely for the higher tier paper, so if you're doing foundation, you can relax for a moment. We're talking quadratic sequences. Now, they can look intimidating, I get it, but trust me, it's a clear method that you can definitely master with a bit of practice.
So, what happens when you check the gaps between the numbers and they're all different? Does that mean the sequence is broken and there's no rule? Of course not. It just means we need to dig one level deeper.
Check out this table. The first difference, the first row of gaps, goes plus 5, plus 7, plus 9. Not constant. But look at the difference between those differences. From 5 to 7 is plus 2. From 7 to 9 is plus 2. Boom. It's constant. And that right there, a constant second difference, is the massive clue that screams, this is a quadratic sequence.
Okay, here's the 5-step method. Stick with me. Step 1. Take that second difference, which was 2, and you have it. Half of 2 is 1. That tells you your formula starts with 1n squared, or just n squared. Step 2, write out your original sequence, and right underneath it, write out the n squared sequence. So 1, 4, 9, and so on. Step 3, now subtract. Find the difference between your sequence and the n squared sequence. This gives you a brand new, much simpler sequence. Here, it's 2, 4, 6. See? That's just a linear one. Step 4, find the rule for that new sequence. The rule for 2, 4, 6 is obviously 2n. And the final step, step 5, just combine the two bits you found, the n squared from the start and the 2n you just worked out. The final answer is n squared plus 2n.
Phew. All right, let's switch gears. Enough of that heavy calculation. This final section is all about recognition. It's about spotting patterns. There are a few famous sequences that you just need to learn by sight. Honestly, these can be some of the easiest marks you'll get in the entire exam.
Here are the big 5 you need to lock into your memory: triangular numbers, square numbers, cube numbers, the Fibonacci sequence, and geometric progressions. Let's do a super quick-fire round of what each one looks like.
First up, triangular numbers. You start with 1, then you add 2 to get 3, then add 3 to get 6, add 4 to get 10. You're just adding the next whole number each time.
Next, square numbers. This one's easy. 1 squared is 1.
2 squared is 4, 3 squared is 9, and so on. The nth term is just n squared.
And you guessed it, cube numbers are exactly the same idea. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. The rule is simply n cubed.
The Fibonacci sequence is a classic. You just add the 2 previous terms to get the next one. So 1 plus 1 is 2, then 1 plus 2 is 3, then 2 plus 3 is 5. Just a heads up, they often use a Fibonacci type sequence in exams, which uses the same rule but starts with different numbers.
And finally, a geometric progression. This is where, instead of adding a number, you multiply by the same number each time. In this example, we're just doubling every term. And there you have it. Let's just quickly recap. You now have the skills to generate terms from a rule, to find the nth term of any linear sequence, and to get your head around those tougher quadratic sequences. You are absolutely ready for these questions. So I'll leave you with this thought. Knowing the method is step 1, but the real challenge, the thing that gets you the top grades, is applying it. Can you use the nth term to prove that a massive number is or isn't in a sequence? Can you use it to solve a multi-step problem? That's your next step. Taking these tools and becoming a real problem solver. Good luck.